our Chapter 6, Fluid Flow Measurements, with its subtopic, Venturi. This is our Problem 2 from 4th edition of Fluid Mechanics by White Frank 6-151. Gasoline at 20 degrees Celsius flows through a 6 cm diameter pipe. It is measured by a modern Venturi nozzle with diameter of 4 cm. The measured pressure drop is 8.5 kPa. Estimate the flow rate in gallons per minute. But before we answer our problem, let's have a short recap about our topic. A Venturi is a device used to measure the flow rate of a fluid by creating a pressure difference between 2 points in a pipe. It is composed of a converging section followed by a diverging section that narrows and then widens the flow path. As the fluid flows through the narrow section, the velocity increases and the pressure decreases due to the Bernoulli's principle. The difference in pressure can be measured and used to determine the flow rate of the fluid. And finally, to solve our problem, given that the diameter of the pipe is 6 cm, the diameter of modern Venturi nozzle is 4 cm, pressure drop is 8.5 kPa, and the density of gasoline is 680 kg over cubic meter. The flow rate can be solved using this formula. Flow rate is equals to coefficient discharge times the cross-sectional area of the Venturi nozzle times square root of 2 times pressure 1 minus pressure 2 over the density times 1 minus the ratio raised to 4. But first, let's solve for the ratio using the given diameter. Ratio is equals to the diameter of a modern Venturi nozzle over the diameter of the pipe. Ratio is equals to 4 over 6. Ratio is equals to 0.667. For flow rate nozzle, the discharge coefficient CD can be solved using this formula. Coefficient discharge is equals to 0.9858 minus 0.196 times the ratio raised to 4.5. Coefficient discharge is equals to 0.9858 minus 0.196 times 0.667 raised to 4.5. Coefficient discharge is equals to 0.954. Solve now the flow rate using the solved coefficient of discharge and the given values. Flow rate is equals to 0.954 times pi times 0.04 squared over 4 times square root of 2 times 8,500 over 680 times 1 minus 0.667 raised to 4. Flow rate is equals to 6.694 times 10 raised to negative 3 cubic meter per second. But let's convert it to gallon per minute. Multiply it to 60 seconds over 1 minute times 264.17 gallon over 1 cubic meter. The flow rate in gallon per minute is equals to 106.11. And that is all for our Chapter 6 Fluid Flow Measurement. Thank you for watching!